In the previous lecture, I was explaining Radix tree as the example for Ethereum state. Of course, in the Ethereum state is not represented by the Radix tree, but there is this similar structure of the tree called Merkel-Patricia tree. Okay, let's continue. Let's introduce implementation of the Radix tree, and in the next lecture, we'll move to Merkel-Patricia trees. Okay, so implementation of these I have prepared for you. You can find on the link in the resources of this lecture, and just simply copy this entire structure to your code calling editors. Okay, so let's copy this entire code. Copy, let's go to your calling editor. In your exp folder, let's create here a new file, and let's call it radix.js. Let's paste everything here. I will give you a very short preview of this. So first thing here, you don't need to notice here, this is just a helper function to transform hex characters into nibbles, basically. All right, and here is a node structure. Node structure, as I mentioned, is just a simple keeping the children, where the children are key value pairs, where the key is a nibble and the value is a node. So this linkage you can see here. This linkage you can see here, tree is pointing to this node here. This is a representation of this nibble and a node. End of word, the boolean false true, and the value itself. Function insert to insert value in the node. Okay. Then the try is a very simple structure. Has a constructor which when you create a new try instance of a try, it will create a new root node. Then you have two functions to put and to search in the try. All right. Then you can have a put key value, and this will add the value as a path of this key into this try. Simply, you will get hexadecimal characters. You will transform it into nibbles. You will iterate through the nibbles, and then you will get a current node. If you have a current node, you can create a linkage. But if you don't have a node, you are creating the new node, where in the current node children nibble will ascend a new node. We can debug it together, so maybe it's more clear to you. But just let's talk about this on this level. When you will traverse the entire node, you will iterate every nibble. You will mark this node as the end of word true. You will insert the value in the node, and add it as a console log for you. The search is similar. You will just simply traverse all the nibbles. If you will reach end of the word, you will just return the node. All right, and then there is an example. Create a try. Put the three values in the try. So those are addresses: 32FA7C with the value 20, 32FA7B with the value 10, and 437B with the value of 5 ether. Then you are searching for these values, and here we are displaying these values, so we are sure that we can retrieve them. When you will run this code, let's run it. Let's first save it, of course. Let's go to your terminal, and you can run it as this node exp radix.js. You should see you're creating this try, and the nibbles are in the following: 3, 3, 3, 2, 6, 6, 6, 1, 3, 7, 6, 3, and then you will create a node which you mark as the end of word, and you will replace the value with the bytes 3 to 30. The same here and the same here. Maybe you are a little bit confused by these values. Why the values of the nibbles are 333 to 666. In the end, the value should be 32FA7C. The thing here is that this is the string word, and when they are transforming it in the area of bytes, it's transformed actually into representation. Each character is represented by some ASCII number. Okay, so let's copy this number, please. 32FA7C. Open your browser and search here for ASCII to hex. ASCII to hex. Okay. Here, rapid tables, and let's place here 30FA7C. So now we are going, or actually you need to go other way around. Oh no, this way around. ASCII to hex. Let's convert it, and you will see these numbers: 332666613763. So that's the representation of this string here, 32FAC. Okay, because every character in the ASCII encoding has some specific number assigned. Okay, if I would write here hello world, this will be a completely different sequence of bytes. Okay. Okay, so that's why you show this number. So this, what I draw here, just for simplicity, that doesn't correspond to the actual Radix tree implementation we have, but the conceptual model is the same. The difference is only how we are treating these values. Okay? So yeah, so if you will transform from ASCII to hex, then you will get these bytes 33, 32, 66, 61, 37, 63. In the sequence of nibbles will be 3, 3, as you see in the terminal. 3, 3, 3, 2, 6, 6, 6, 1, 3, 7, 6, 3 at the value of a buffer 30 to 30. Again, this is in a hexadecimal format now, so we need to transform from hexadecimal format here, so 30 to 30. Again, to the browsers, now you can swap here, and you need to go from hex numbers to ASCII. So 30 to 30 convert, you will get 20. Okay? The same with the value here, 3130. 3130 will be, 3130 will be 10. 3130, 10. And then the last value, 35. 35, convert, and that's a 5. Okay, so now we're going from hex numbers to ASCII encoding. Okay, so that's basically how it works. Now you can see it. We basically created the same representation of a trie as you could see as I would draw here. Okay, so the path of the nibbles point me to the value. Okay, maybe you want to debug it. You can debug it in the following way. Let's navigate to radix.js. Let's find the line of the code where you want to place a breakpoint. So from which point on you want to debug. Let's say when we were adding this first key here, 32FA7C. So I'll place here a breakpoint on this line, 73. This will create this red dot. I'll go to the left side to click here on and debug, and I will click here on and debug. And maybe you are asked here to choose some configuration. If you are seeing their configuration, please choose their Node.js. You should be asked to choose the Node.js. Okay, so one more time. Place the breakpoint, click here on and debug. Maybe you're asked to choose Node.js. So click on this and you should be seeing this yellow line at the breakpoint. So we are putting the value to the trie, which we are transforming here. So we are taking 32FA7C and we are creating from this buffer. Okay, buffer will create a sequence of bytes. Okay, so when I will step into here, so this is step into this arrow down, it will get me to the function put. When I will click step into, if I would put here this arrow, this would step into the next line. So I'll click here this down arrow to step into this function. I'm now in the put function and have here this key. Okay, buffer of six items: 51, 50, 102, 97, 55, and 99. This is in a decimal format. These bytes are in a decimal format now. So what I want to transform them now is to the hexadecimal format and to the nibbles. All right, so these represent this 32FA7C representing the sequence of these bytes in the decimal format: 51, 50, 102, 97, 50, 55, 99. All right, so let's see what will happen when I will transform it from a decimal to hexadecimal. Okay, so let's go to a browser. Let's search here for a hex to decimal. Okay, so first number was 51, right? So check here decimal to hexadecimal. Get here 51, convert, and you will get 33. And you will transform 33. So from a hex to ASCII, 33, convert, this is a 3. That's the value here, 3. Next sequence of decimal is 50. Again, from a 50 from decimal to hexadecimal, 32. 32 here, 32, convert, 32. This is the value here. Get the point? 32. Now let's continue. The next sequence is 102. So from a decimal 102 to hexadecimal, it will be 66. 66 here. Convert F. Okay. The 2 that we added F. So you got a point. So that's this key what we are adding here. 32F. And if you would continue, you would reach the entire key. So you are getting this key transformed. All right. And then from a buffer to nibbles, you'll transform it into a hex format. And from a hex to the nibbles. So now you get these nibbles here. 3, 3, 3, 2666137132, as I explained before, right? So that's the sequence of the nibbles you are getting. All right, guys? So that's what I was explaining here, that from this 51, we get a 3-3, and that's the sequence of these nibbles, okay? So that's why we are starting here with a 3-3. So that's the entire sequence of the nibbles, and then we are simply going to iterate through them. So we'll step into here. So I'm in the iteration, I step the down arrow twice, so I'm inside of the iteration now. I'm iterating the nibble, so we'll get the first nibble, which is a 3. Get me 3. I'll check here if my current node, which is pointing now to the root node, is containing this nibble. And of course, it will be not pointing to the nibble. It will be undefined. So if you don't have a node, we'll create a new node. Okay? And to the current node, children at this nibble 3 will add this new node. And we'll place the pointer of this node we have created to the current node. So in next iteration, we are on the current node. Okay, so that's how we are moving in the iteration. The next nibble will be again 3. Then if we have a node on the children, we don't have because we are just creating the new nodes. So new node, we'll place on the nibble the new node and place the pointer to the current node. And that's how we'll iterate through all of these nibbles. And we'll reach the end. It will be iterating 12 times, right? With 12 nibbles. When we'll reach the end. Okay, we'll go through all the steps. We'll reach the end. We'll mark the current node, which will be last one, as the end of the word, true. We'll insert their value, 5048, which is again in the decimal format. Then you will transform this to the hexadecimal format and to the ASCII. Then you will get the value. I can prove it to you. 5048. Okay, so again, 50, 32, and 48. 48. Convert 30. Convert 20 ether. Okay? So that's how you will iterate through all of them, and you will place the value to the try, and you will do it with all of these, and then you will search the try. So basically, when you will step into here, search, again, I will get sequence over the nibbles for current key, which is this sequence of the nibbles, again, as we had added before. Basically, we'll iterate through all of them here, again, in iteration, and if I will reach the end, that should be my ending node, and I should return the last node. Okay? Okay, and if node would be null, then we would just simply return from here, okay? Okay, so we are just moving pointer to the path, and then when we reach the end, we'll just simply return the current node, and this will get me this value. 5048, which you could see was 20 ether. Alright guys, so that's just the implementation of the try we have drawn here. So as I told you, this you are transforming to buffer, which is a sequence of bytes in a decimal format. So what you will get here is a decimal format of the bytes. You will get this sequence of bytes in decimal format. You will transform them into hexadecimal format, and you will transform it to the nibbles. So you'll get 12 nibbles. You will iterate through all of them. When you will reach the last one, you will add the empty node where you will assign the end of the word to be true and insert their value of 20 ether. Same apply for every key value pair. When you want to retrieve them, you get a key. Again, you will extract from the nibbles, so you know what path to iterate through. You will iterate the entire path and you will retrieve your node. That's the entire point of this. And you can see when you will place the breakpoints and you will run and debug, you can simply debug your entire code. I understand these topics can be a little bit difficult to understand. If you have any problems with this, just keep asking questions. I will try to help as much as I can with these topics. Alright, so it's gonna be it from the Radix tree. Now we are going to move to really difficult stuff. Alright guys, I hope to see you in the next one. Cheers.